Okay, let's pick up where we stopped. Now, we were talking about D in this example. What quadrant is 2A in? Now, you may notice that the sign of A was going to be 4 over 5. Now, that's not in the unit circle, so we're not going to get an exact angle for that. So we're going to have to use a calculator to get an approximation. Now, to do that, we're going to write the inverse sine of 4 over 5. Put that in the calculator, and we're going to see this is approximately 53 degrees. Now, if we double that, we get 2 times 53 degrees, which is going to be approximately 106 degrees. Now, on the unit circle, we can see that we go 106 degrees is going to be greater than 90 and less than 120, so it's somewhere in here, and that's quadrant 2. So the answer is going to be quadrant 2. Okay, let's move on. Now here we're going to express, no, I'm going to do number 5 here. We're going to verify this identity here. Well, actually, we've done a number of those. Well, this one has a double angle in it, so it's a little different. Sine of x over the sine of 2x equals 1/2 the secant of x. Now I have two different angles here. One of these angles is x, the other one's 2x. So I'm going to have to write them in terms of the same angle. So Alexa, stop. That was my timer. It did not work correctly. So sine of x, and using this formula here, I'm going to write the sine of 2x as 2 times the sine of x cosine of x. And I want that to equal 1/2 the secant of x. Well, the sine of x cancels out, and I'm left with 1/2 times 1 over the cosine of x. And 1 over the cosine of x is just the secant of x. So this is 1/2 the secant of x equals 1/2 secant of x. And that checks, so we've done that. Now the next thing we're going to look at is these half angular formulas. Now they work pretty much the same way as anything else here. So in this case here, I'm going to do A. Get another sheet of paper. And I'll rewrite this. The sine of A over 2 and the sine of A, I'm given this, is negative 4 over 5, and A is between 180 degrees and 270 degrees. So that means it's in quadrant 3. So let's sketch this. Now this is not to scale. This is a sine is going to be negative 4 over 5. So this is going to be negative 3. And that's a 3, 4, 5 triangle. So what we know is the cosine of A is negative 3 over 5. Now the formula says that the sine of A over 2 is equal to plus or minus the square root of 1 minus the cosine of a over 2. So this becomes plus or minus the square root of 1 minus a negative 3 over 5 divided by 2. This becomes plus or minus the square root of 8 over 5 divided by 2, and I can simplify this argument in here. This just becomes plus or minus the square root of 8 over 10, which is the same as plus or minus the square root of 4 over 5, and I can rewrite that as plus or minus the square root of, I'm going to just write this differently, plus or minus 2 over the square root of 5. Now, if I want, I know that in quadrant 3, sign is going to be negative, so I'm going to go with the negative sign here. So sine of 2a is that true though? No, it isn't. It's not going to be in quadrant 3, it's going to be in quadrant 2. And the reason for that is if we take half of this, we're going to be somewhere between 90 degrees and 135 degrees, so we have to be up here. So we're going to be in quadrant 2. Now, I don't need that for now, but I'll get back to that. So the sine of a divided by 2 is going to be the positive, and if I rationalize that, I'll get the square root of 5 times 2 over 5. I'll move up a little so you can see that. Now, the quadrant this is going to be in, we know the angle has to be in the third quadrant, so this is going to be somewhere between 180 degrees and 270. Now, if we take half of that angle there, it has to be between 90 degrees and 135 degrees. And that means it's going to be in quadrant 2. Okay. Now the rest of it is just homework, and the homework is in there. I think you've got enough examples to get through that. If you get stuck on something, either shoot me an email or try to catch me when I'm in I don't know how long I'll be in the conference room today, but in Schoology conference, but I have another meeting with the principal. But send me a message and I'll make another video and stick it in here, and you can go back and look at it again. And I'll try to get that done today. But again, this assignment is not due until tomorrow, so you've got plenty of time to work on this and get your questions answered. Okay, I'm going to stop this video here.